Okay. And I'm here to present a study we titled Fast Synthetic Data Generation for Case-Specific Entity Extraction in Criminal Investigations, and I'll come back to that. Let's see. So within the next 12, 13 minutes, I'll give you an overview of my PhD research project, and then I'll present our study on synthetic data generation for fine-tuning a named entity recognition model. And then I'll also share my thoughts on my future directions for my work. So my research topic is really to try to suggest a framework for semi-automated information analysis in criminal investigations. And this is closely linked to the field within natural language processing, I would say. So when you guys within the digital forensics domain doing your job, we have all the other specialists in ongoing criminal investigations. So you're very familiar with, you have the interviews and you have crime scene forensics and everything. So everything comes into a hub of information, very often mentioned as or referred to as the case file. And these are as still today, and I believe for many years on, documents with unstructured text. So I'm really digging into these documents, trying to process and connect the dots in an ongoing investigation. So far, I'm 3 years into my PhD, and some of the work we have looked at so far is that we have tried to specify and define information analysis in criminal investigation, which I just mentioned now, and also trying to bridge it to computational methods. We have identified and selected a few methods, and one of those are named entity recognition to process these police documents. I'll come back to that. And then also we've done a work where we tested semantic textual similarity because throughout an investigation, there's always these information needs coming up and shifting throughout the investigation. So there's really a challenge for us well, my experience is that very often in these investigative meetings, there's always new question coming up, and then where do you go to actually find your answers? So it's always like, did someone hear about a red vehicle? And then the next week there's another one and another one. So we try to look at semantic textual similarity instead of key string matching and reading all documents. And then also we've done a study on retrieval augmented generation. With similar purpose to try to identify relevant information in ongoing investigations more effectively. So, however, I'm here to present a study we did, and we titled Fast Synthetic Data Generation for Case-Specific Entity Extraction. So to break down this title, what we did, we generated synthetic data using an LLM for training and for fine-tuning a case-specific entity extraction model. And one challenge we wanted to tackle here is that one named entity model may work well within a cybercrime-related scenario, but then it might not work as well in a different case scenario, let's say a homicide. So really I want to test if it's possible to do fine-tuning of models throughout an ongoing investigation. And when we refer to the term criminal investigation, we really focus on all of the collected sources to information. So it can be any source of information, but we're really focusing on connecting the dots within all these documents that are generated throughout an investigation. And as you might hear, this is a bit on the side maybe on digital forensics. I don't know, it's up to you to decide, but I will very much invite you in to help us out with these issues. If you see it as mainly partly on the side of how you look at digital forensics. What we did in our paper, we started by presenting an ontology This is from within the Norwegian Criminal Investigation Service, and it's very much of a standard for any criminal case. But then the subclasses here can differ very much depending on the different cases. So some of these classes are really broad, but this is where we started out, and we presented this very much used ontology for entity classes. And then why do we do this? What's the challenge? The challenge is that it's very time demanding and resource demanding to index all the generated police documents. So that's why we have the document reader, we have the indexer, the indexing supervisor, and so on, action manager. All of these roles are really to handle all the incoming and all the generated documents. So we have a data set of 2 homicide cases, and within these 2 cases, there were 4,321 entities manually created by the investigators and 13,379 manually generated links. And almost close to 100 investigators involved throughout these 2 investigations. So there's the motivation for some automatization of this process. So what we did, we used the confidential data set as inspiration. We took lookalike sentences and gave this as an input to Claude, the LLM we chose to use. And we generated 817 synthetic sentences and 1,458 entities. And then we also manually annotated 25 sentences within the confidential data set where we ran the model afterwards on this confidential, still unseen data set. So we've basically fine-tuned a Scandi NEAR model, which has been previously fine-tuned for Scandinavian languages. And to jump over to our findings or results, we saw that we got really good results on the synthetic data set. A correctness level, a combination of the precision and recall of the weighted average at 94.2%, which is really strong. However, when we ran it on the confidential data, we saw a performance drop. So we got a weighted average of 81.6%. And why did we see this performance drop? I definitely think that it has to do with our main limited data set. Should be we should enlarge our data set, and also there is still a challenge related to the linguistic patterns here. Even though we use confidential data as examples or as inspiration and get really lookalike linguistic patterns, there's still some gap to work on here. However, the scenario here is really an ongoing investigation, a new, let's say, domain, and then to what extent can we apply this fast method to come up with a fine-tuned case-specific named entity model. So as a conclusion, our conclusion is that testing this method, we would say that it looks like we can use LLMs for synthetic entity labeling data generation and train lighter weight models. So we should look more into this. And our data labeling approach encourages easy and humanly understandable transfer of labeled data for analog police work to training data for entity extractions. And also part of our work, we have shared our data set, which is in Norwegian. But I think it's been mentioning this morning, you're very familiar with the challenge when it comes to data sets. So we want to encourage and work upon that challenge, especially when we're working with confidential data sets. And last slide for my work and my future work. I'm interested, we're doing a study now where we're looking at the information management system in criminal investigations. So it's really, again, any source of information is collected into this hub where investigators identify some information to follow up on. So it's really there's an activity or action module in this system. So we really want to try to see what is criminal investigation through the lens of its information system. And what else? Yeah, so that's one study ongoing to, of course, try to identify how we can improve these systems so they can facilitate and support the investigators. Also, we're doing a study on knowledge graph for exploratory information analysis, where we try to automate the knowledge graph generation within these two homicide cases I presented. So to see, let's say, compare and contrast what the investigators manually do, and then see how close can we get, so to say, if we semi-automate that process, so towards the knowledge graph. So that's also an ongoing study. And that was all from my side. Thank you